So today actually we'll be starting with a new topic. So that is power electronics and electric drives. So power electronics and electric drives, right? So this topic actually is one of the very important topic, and many people feel that this is a tougher topic. But in reality, actually, it's not a tough topic if you know basics of the mathematics. So that's why actually many people feel that actually it is a tough topic because it involves a lot of analysis. So the complexity that is involved in this is so one is actually it involves analysis. So this is one fact, and the second fact is a lot of mathematics is involved. Right. So these are the two reasons actually why many people actually feel it is a difficult subject. Right? Seems to be a difficult subject. Right? And so we will discuss actually what are the syllabus actually that is involved in this, and then actually we will see the important aspects of it, and we will go through the previous year questions also, and then actually we can understand what are the books that needs to be referred. And also I'll just actually try to answer few questions. One is what is the syllabus? And the second one is what are the books to follow? And third one is, right, weightage of this topic. The fourth one is approximate number of hours. And the fifth one is, right, so books, syllabus, weightage, and previous year questions. So these are all the questions actually I will be answering, and then actually if you want you can add me any of the questions actually if I miss it. Now first actually let me write down the syllabus, then actually we can understand what syllabus he is talking about. And this is actually a very short syllabus. This is a very short syllabus. But actually the number of concepts involved is more. So short syllabus actually, so each topic involves more concepts. Right, so this is one fundamental problem. And then actually practice is a must, not like other subjects. So don't compare this subject with networks or actually EMTL or actually machines or power systems. And this topic actually you need to practice. There is no shortcut in this. The reason behind the practice is it involves actually a lot of mathematics, and it seems to be an easier problem. When you solve it actually you will face a lot of difficulty because actually complex mathematics is involved. Right, complex mathematics along with analysis. Right, and let me write down the syllabus actually what he is talking about. And this syllabus is semiconductor power devices. In that, semiconductor power devices. So in that actually we have diodes, right? So diodes, transistors, thyristors, triac, GTO, diodes, transistors, right? Triac, GTO, and MOSFET. MOSFET, right? And these are all the devices actually that we will be learning, and then static characteristics and principle of operation. In this actually the static characteristics and principle of operation. Principle of operation. Triggering circuits, phase controlled rectifiers, bridge rectifiers, triggering circuits, right? So triggering circuits, phase controlled rectifiers, bridge converters, bridge converters, fully controlled and half controlled, fully controlled and half controlled, principle of thyristor choppers and inverters. Principle of thyristor choppers, right? Inverters, DC to DC converters, so DC to DC converters, switch mode inverter, basic concept of speed control of DC and AC motors, switch mode inverters, basic concepts of speed control, DC AC motors, application of variable speed drives. Right, so this is the complete syllabus actually what we are going to discuss as part of this particular topic. And then actually let me go through this particular syllabus, right? So what we are trying to understand is, first of all, actually, why there is a need of power electronics. That is the fundamental question that we will have to answer first. So why there is a need of power electronics? Because we already have the electronics subject, right? So electronics subject is there. to deal with the electronic devices and then actually the applications of the electronic devices. But what exactly makes the fundamental difference between the normal electronics and the power electronics is the only one single fact that the power that needs to be handled is very, 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 very high. So this is the only difference. So when you see any of the electronic devices or actually any of the electronic circuit like the motherboards or actually the CPUs and all such kind of devices, if you notice, the high voltage is actually only 5 volts is the highest voltage usually in any of the electronic circuits. That is one important fact. Another is the power that needs to be handled is only of the order of milliwatts, not even the watts, milliwatts. And milliwatts of the power, actually the amount of the heat that it is going to generate is actually very, very small. Now, coming back to our power electronics. So the power electronics actually, the device main constraint is to handle the power. So let us say actually there is a diode, and the diode actually, imagine that if it is passing only 1 milliampere of the current and then actually 1 volt if you apply, then actually the power that is going to be handled is going to be only 1 milliwatt. But the same diode, if I apply 1000 megawatts, 1000 megawatts of the power actually, let us say actually 440 volts actually I have applied across the diode and the current actually that is equivalent to 1000 megawatts of the power. Now actually the problem comes. So is the diode actually will be able to withstand or not? That is the fundamental. So there is a huge amount of power actually when it is passing through, then actually it is going to burn out immediately. So this is the fundamental problem. So the power that needs to be handled is different. Now, if this is the only fact, then actually what else exactly actually we will have to learn, right? Yeah, it will not withstand. So that means actually here actually we will get an important clue in our understanding of the subject. The important clue is the working principle of the electronic devices, what we learn in the analog electronics, like the diodes or the transistors or the MOSFET or FETs or whatever it may be. Everything, whatever we learn in our normal analog electronics, actually the working principle, there is no difference. There is nothing new. You are going to learn it here. So this is the first thing. That means if you are good at electronics, then actually you are good at power electronics also. This is the fundamental thing. So working principle actually is exactly the same. By construction, it is different because it needs to handle a huge amount of power. So the size of the diode is very, very big, but the working principle is same. The size of the transistor is actually very, very big, but exactly it is like the normal transistor. There is no difference. Got it? So that means actually the working principle, operation, everything is actually exactly the same. The power is actually by construction actually it is different because it needs to handle a higher amount of the power. So this is one fact. So it gives actually a lot of clarity for us that actually you are nothing new. You are going to learn it, right? So as the working principle perspective. So that is actually the first part. Actually, semiconductor power diodes. So power devices in that actually diodes, transistors, and triac GPUs and MOSFETs. So in that actually and right MOSFETs and SCRs actually not listed. So there is an SCR also. SCR, silicon control rectifier, right? And now actually in this particular syllabus, these devices actually we will be learning it. The working principle actually we will try to understand it, but 90% of the time actually we will spend on only two different types of devices. One is the diodes and the SCRs. Because actually rest of the subject what we are going to learn, except for the fact that for understanding the device actually we will learn the basics of these things. But all the applications what we are going to analyze in the class and even in the examination, even in the syllabus actually, it is simply the diode and the SCRs. And usually actually there is no difference, fundamental difference between the diodes and the SCRs, except for the fact that it works like a rectifier, but it's a controlled rectifier. That means actually you are controlling the amount of the voltage that is going to be giving us the output for the same amount of the input voltage. So except for that fact, diode and actually the SCRs actually by construction actually maybe it is different, but the working principle more or less it is same. At least from the application perspective actually it is the same. So in the rest of the devices, for the sake of understanding, we will understand same working principle like normal electronics. And then actually, so these static characteristics and principle of operation and the triggering circuit. So this is a new concept actually we are going to learn it here. What is this triggering circuit is? SCR actually by default actually it won't turn on even if you connect a forward biased voltage. So diode actually the fundamental difference between the diode and SCR is it is still the diode only. So this is the diode. And this diode actually, if you apply positive voltage here, negative voltage here, actually it will be forward biased and then actually the current is going to be flowing there. And then actually, suppose the SCR actually, it is the same, but except for that there is a wire actually that we will keep it here, and this is called as a triggering. So that means even if it is forward biased, unless you give a input voltage at this particular terminal, it won't turn on basically. That means the diode and the SCR actually is exactly the same. Only thing is you will have to give an external signal to say that start conduct. So that is why actually this is only a difference actually that you can notice between these two, and except for the fact that actually the output voltage actually you can control it. That is the amount of the waveform what it is going to conduct actually that you can control in case of SCR, but in case of diodes we cannot control it. Got it? Now actually, so this circuit actually, so at a specific instant of time of the waveform, we will have to trigger so that actually the next waveform is going to be conducted. That's why actually there are separate circuits actually that we will discuss called as the triggering circuits only to connect to this SCR. So this is actually a separate concept. And phase controlled rectifiers is nothing but same the bridge rectifier and half wave in converters what we learn in case of electronics, right? Diode converters actually we will learn, right? The same thing actually even here also we do it, but instead of diodes we will use the SCRs, then we call that as the phase controlled rectifier, because actually you are controlling the amount of the phase of the voltage actually that you can control. So that's actually we call this as the phase controlled rectifier. So that means actually full wave rectifier and half wave rectifier we will rediscuss with the understanding of controlling the waveform. Right? So this is one thing. And then actually bridge converters and the fully controlled and half controlled rectifiers. So that is fully controlled and half controlled rectifiers means in the bridge converter, that is the bridge rectifier is there, right? So bridge rectifier actually if you use SCRs, then actually whether you wanted to control all the 4 different SCRs or actually you wanted to convert only 2 different SCRs, you will control it, and the rest of the inverter segment, so rest of the SCRs you can replace with the diodes. So that's what we call as the half controlled rectifier and the full controlled rectifier. Half controlled means we will keep 2 diodes and we will keep 2 SCRs, and these SCRs actually we will control it. So that is called as half controlled. And fully controlled is actually we will control all the 4 devices depending upon the application requirement. So there are actually special applications because the amount of the power it is going to conduct in the forward direction and backward direction actually that doesn't matter in case of fully controlled rectifiers. Got it? So that actually we will discuss in this particular case. And then actually principle of thyristor choppers, inverters, DC to DC converters. So choppers means actually, so that is the DC to DC converters only, these choppers. Choppers actually basically the amount of the DC output voltage you wanted to reduce the average voltage. For that reason actually the choppers actually we will try to chop it. Chop means actually we will cut it. So the waveform actually it is a flat waveform, and we are cutting in between so that the amount of the average value actually is going to be reduced, and that's what we call as the choppers. And then actually AC to AC, so the DC to AC converters and AC to DC converters. So all those things we will be learning. AC to DC converters is nothing but the converters, or the actually just the bridge converters or the half controlled and full controlled rectifiers. We call that as the rectifiers. And AC to AC actually that is we will control the amount of the output voltage with the help of these inverters, and that inverter voltage is actually we will take it to the outside world. So that actually so we will be learning the inverters also, and choppers also we will be controlling it. So we will be learning the choppers to reduce the amount of the voltage. Basically actually in and around, if you notice, entire topic is actually targeting a single point. What is that single point? Only one value, that is the amount of the voltage actually we wanted to control it. So that is the only single agenda of this entire topic. Why we need to control the amount of the voltage? Because you wanted to control the speed of the drives. So in the previous classes actually we learned the electrical machines. So DC machines and AC machines actually we learned it. And in all the machines actually you can notice that actually voltage control method is actually one of the best method, so that actually you can get the constant amount of the torque for the output, right? For that reason actually the amount of the input voltage that you give it to the drive is directly proportional to the torque that is going to be generated, or actually the speed that you can control. So for a constant torque, the amount of the speed is controlled by giving the input voltage. So the input voltage by means actually we need, in case of AC actually the RMS value actually you can control it. In case of DC you wanted to control the average value of the input voltage to the drive. So drive means motor. There is no difference between the drive and the motor. It is exactly the same. Drive actually the word actually we use in the case of industries where actually it is used for some kind of application to drive. Hence actually we call that as the drives. But our name is electrical motor. There is no difference. Got it? So that drive input voltage actually you wanted to control it because you wanted to control the speed of the industrial motor applications. Hence actually the amount of the voltage you wanted to give it, for that actually you can use these AC. So these converters are actually the power electronic devices, you can make use of it to get the control. But actually you might be thinking that actually why can't we use the transformers as well? Got it? Exactly. So the power electronics devices is just to handle the high power indirectly, high voltage and high currents. That's it. That is the only purpose. There is no other purpose. Right? By working principle, there is no difference between what you learn in analog electronics and the power electronics. By working principle, 100% same. And the only application of these power electronic devices is to control the drives. So the drives, actually the drive speed you wanted to control it. For that actually the amount of the voltage actually that you wanted to control it. For that reason actually we will use these rectifiers, right? And so you might be thinking that actually even the transformers also can be used to control the amount of the voltage that will be given to the motor, right? Because the transformer is having the capability of increasing the voltage or decreasing the voltage. You can use the same thing. But the problem is transformer is a mechanical device and you wanted to control the speed smoothly. So even 0.1 volt also I wanted to control it, or 0.2 volts also actually I wanted to make the difference so that the speed is going to be different. But in case of transformer, you cannot do that. So such a smooth variation of the speed is not possible with the mechanical equipment like transformers. But in case of electronics actually, so power electronic devices, so you can just change the triggering angle so that actually you can control the amount of the input voltage that you can give it. So for DC and AC actually it is the same type of equipment actually that you can make use of it, so that actually you can control the AC motors and you can control the DC motors also. And the other applications actually we have the inverters. So where actually the inverters actually we will use, so we will take the power from the AC source and then actually we will try to convert into DC and store in the batteries. And the batteries actually, and when the power is lost, the battery power actually is the DC, and that we will take it and then actually we will convert into inverters, right? We will take the help of the inverter and then we will generate the AC voltage waveform, and that value actually we will give to the houses, right? So like this actually these are all the applications. So we concluded that two important facts. One is actually no difference between the normal analog electronic devices and the power electronic devices, except for the fact that to handle the high power, the size is going to be different and the cooling that you need to provide extra, all these things actually we will take it. So that means actually the mechanical aspects are different, but electrical aspects are 100% same. So this is the first thing you need to learn. And the second thing is actually the purpose of these power electronics is actually to handle the, so to control the voltage. So the voltage, if you control it, then the amount of the power you can control it, then the current you can control it, so that actually the drives are actually getting controlled with the help of these power electronic devices in a smooth way. So this is the only purpose of the power electronics. Now in that actually we can imagine multiple applications. So whether you wanted to give it to a DC or actually you wanted to give it an AC, and whether you wanted to use a bridge rectifier or actually you wanted to use a half controlled rectifier, you wanted to use the diodes, or actually you wanted to use the transistor, or you wanted to use the SCR. So depending upon the type of devices you are going to use it to control the voltage, the applications and the analysis are completely different. Got it? So this is completely what we are going to learn as part of this power electronics. I hope you understood. Any questions? Right? Okay. So this is the syllabus, and in this actually, so the last part is actually switch mode inverters. So this is actually the amount of the voltage that you can control in the inverters. And then actually the basic concept of a speed control of a DC and AC motors and applications of variable speed drives. So that is actually in some cases actually we will use the not in some cases, in most of the cases actually we use the variable speed drives. That is actually, as I said earlier, so paper industry is one actually where you wanted to control the speed smoothly, and those are all some of the applications. Basically these are motors only. Motor voltage you are going to control. That's it. Got it? So this is the syllabus what we are going to learn, and then actually. So we understood what is the syllabus. Then actually what are the books that needs to be followed. So I follow actually, there are two books with me, but actually I follow only one book, right? So this book actually I will follow. So this is PS Bimra, right? So PS Bimra, Power Electronics, this I will follow. But there is one more book with me, but actually I'm not very much convenient with this particular book. That is actually Rashid. So this is the Power Electronics by Muhammad Rashid, right? So these books actually you can have it, but PS Bimra I will follow. Got it? And so power electronics by PS Nimra. And then actually weightage of this particular topic is actually 70 marks or sometimes 60 marks, not lesser than this. So 70 or 60 marks actually you can get it. And approximate number of hours actually I think somewhere around 30 hours I'll take it. Right? And then actually previous year questions actually I'll just go through what are the previous questions actually that are there. So in 2021 actually we can see that actually a step down DC chopper is feeding a load of R equal to 10 ohms and L is equal to 20 millihenry. The DC supply voltage is 100 volts. The chopper is switching at a frequency of 2 kilohertz. With a duty cycle of 50%, determine the load current and the peak to peak ripple current as an absolute value and as percentage of DC. So this is actually the question. Actually, it is a problem that is related to DC choppers. Right? So that actually you can notice that actually the questions are actually not from the theoretical background. That's actually the working principle, construction, all those things. Actually, you don't need to be worrying about it. And it is mostly the problems actually that will be given in this. As I said earlier, the complexity of the problems also, it's not that easy. So it is a bit complicated. And this question actually stoppers and it is a problem. And then actually the second one is actually a three-phase bridge inverter shown in the figure 6b is used to feed a Y-connected resistive load with R equal 10 ohms per phase, and the DC input to the inverter is 400 volts and the output frequency is 50 Hz. If the inverter is operating with 180 degrees conduction mode, then compute the RMS value of the load current, compute the RMS value of the current in each switching device, and calculate the output power, and draw the waveform of the phase and line voltages. So this actually a three-phase inverter actually that was given. So right, a three-phase bridge inverter. So this is actually a three-phase inverter that was given, and based on this actually he asked us to calculate the voltage and currents in different cases. And this is a star connected load. For the star connected load, and we will have to calculate for each of the device actually what is the amount of the voltage and current. And this is a three-phase full wave thyristor bridge converter is operated from a three-phase Y connected 220 volts 50 Hz supply, and the load resistance is 20 ohms. It is required to obtain an average output voltage of 50% of the maximum possible output voltage. Determine the following. So the delay angle alpha, the RMS average output currents, the RMS and the average thyristor currents, the rectification efficiency, and the power factor. So these are all the values that he asked us to calculate, and you will have to understand the three-phase. So if you notice actually in 2021, two of the problems actually that are related to three-phase. One is three-phase inverter, another is three-phase converter. So inverter and converter both are problems only. And this is actually a 220 volts 1500 rpm 10 amperes separately excited DC motor has an armature resistance of 1 ohm. It is fed from a single phase fully controlled bridge rectifier with an AC source voltage of 230 volts and 50 Hz. Assuming continuous load current, determine the following. So motor speed at the firing angle of 30 degrees and the torque of 5 Newton meters, right? And develop a torque at the firing angle of 45 degrees and speed of 1000 rpm. So this actually both the electrical machines you need to understand, and at the same time you need to understand thyristor concepts as well. So both together actually he continued to give this particular problem, right? So this is also a problem related to DC shunt motor with power electronic devices. That's it. So all are actually four problems, and all the four problems are actually textbook problems only. No worries on this. So textbook problems only directly actually he gave it, and these problems once you understand the concept actually you will find it easier. But now actually you will face a lot of difficulty in understanding this, but once you are done with the topic you will be able to understand easily. In the next one actually 2020 also we will see. So this is in figure. So the ideal switch S is switched on and off with a switching frequency of F equal to 10 kilohertz. The circuit is operated in steady state at the boundary of a continuous and discontinuous conduction, so that the conductor current I is shown in the figure. Find the values of on time, that is T on of the switch, and peak current of conductor IP, right? So the peak current actually he asked us to calculate, and then actually the on time also actually he asked us to calculate, and this is the waveform actually that is going to be given for this particular circuit. So this circuit actually needs to be analyzed with the help of the ordinary differential equations, actually we will have to use it to analyze. And then actually the switching frequency that was given, based on the switching frequency of that switch, actually we will have to calculate for this particular waveform. That is the on time actually we will have to calculate, and the peak current also we will have to calculate. Got it? So this is a problem, and this is actually related to choppers. And this actually shows a step up a DC to DC converter with ideal devices and elements. In its steady state analysis, the output filter capacitor is assumed to be very large to ensure a constant output voltage of V0 is equal to V0, and the switch is turned on and off periodically with a frequency of Fs and duty ratio of D. And with the help of a neat waveforms, find the expressions for peak to peak current, ripple. So ripple of conductor, that is IL, and then actually output voltage ripple, that is delta V0, at steady state in terms of the circuit parameters and variables. And here actually in a step up DC to DC converter, and VD is equal to 12 volts and V0 is equal to 24 volts and I0 is equal to 0.5 amperes and L is equal to 150 microhenry, C is equal to 470 microfarads and Fs is equal to 20 kilohertz. Calculate the peak to peak output voltage, ripple value, and the RMS value of the ripple in diode current, so which also flows through the capacitor. So this actually he asked us to calculate the ripple factor in this particular load, and then actually he asked us to calculate the value of the output voltage, that is the VC. So this is V0 output voltage, DC average value he asked us to calculate, assuming that the C is actually very large, so that actually it is going to be a smooth voltage, actually it is going to get it. Got it? So this is actually a converter, and this is a chopper, because I think there is a switch. So this is again a chopper problem. And this is an SCR having a turn on time of 5 microseconds, latching current of 50 milliamperes and holding current of 40 milliamperes is triggered by a short duration pulse and is used in the circuit shown in the figure. Find the minimum pulse width required to turn on the SCR. So this is actually related to triggering circuits. So this actually SCR triggering circuit, actually we will have to calculate it. So this actually, if you notice, so from the previous key questions, actually I can conclude one important fact, that all the questions are only problems only, no theory. So this is the first thing you need to understand. So all the problems, actually it is only the problems, and the problems actually related to, so I have seen actually the problems related to choppers, problems related to converters, problems related to three-phase converters and three-phase inverters. So these are all the areas actually that were focused more. And then actually you need to understand the so the circuit analysis actually you will have to understand. So from this actually I can conclude that one fact, that you don't need to learn anything related to the working principle, except for the fact that actually you need to know the working principle, like the case of the analog electronics. In analog electronics anyway we will cover how the diode works and how the transistor works, how the FET works, all those things actually we will cover in detail in case of analog electronics. But here actually we focus more on applications, because all the questions are actually related to applications problems. That's it. Got it? So now actually the triggering circuit you need to understand, converters you need to understand, inverters you need to understand, choppers you need to understand, the working principle of these applications as well as the problems related to those. And it demands a huge amount of knowledge from the ordinary differential equations and the interpretation and analysis and all, right? So I have already covered actually that knowledge as part of the network analysis. And if you have any questions, actually I will cover now also if you want. Otherwise, actually we will straight away proceed and then actually try to solve it. There is only one thing that you will have to learn, that is the first order linear differential equation solution that you will have to understand. So that is, if the differential equation of this particular format, first order linear differential equation is, so dy by dx plus p of x into y is equal to q of x. So if this is the differential equation, then the solution is y into integrating factor is equal to integral q of x into integrating factor into dx plus c. And in the integrating factor, actually this is e power integral p of x into dx. So this is the integrating factor. And this solution actually we will use it. So this is the only thing actually that we will use in almost all the problems. And also actually you need to understand that actually what is a steady state solution, what is a transient solution. So steady state solution, actually you can see that actually even if you try to solve an RL circuit, you are going to get this way. So this is actually V by R into 1 minus e power minus t by RC. So if an RC circuit you take it, and this is the value of the output voltage V0. Now in this case actually this is V by R minus V by R into e power minus T by RC. Now if you notice, this value is independent of time. So this is actually independent of time. This particular solution actually we call this as the steady state solution because it is nowhere related to time. So irrespective of whatever may be the time, this current actually always flows. But this current actually is an extra factor. So it will be there initially. Eventually, as t goes infinitely, it will become 0 because e power minus t by RC, and t infinite, then e power minus infinite is going to be 0. And so it loses its influence actually over the time. It loses its influence. Over time. And this solution we call as the transient solution. So this is called as a transient solution. So in case of second order differential equation, the terminology actually we use is the complementary function and the particular integral. Particular integral is the one actually which is the steady state solution, and the transient solution is the one that is the complementary function in case of ordinary differential equations terminology, right? And initial value and final values actually you can see that actually, so for the transient solution actually that initial value is straight away V by R itself, but the final solution is going to be 0, right? So that is initial value, final value are just dependent on the time. When t equal to 0, what is the value? When t equal to infinite, what is the value? That value is actually you can calculate on this. Now, it is purely the circuit theory or the network analysis, what we have learned earlier, we will be reusing it here. So, that is for the AC circuits. In the case of network theory, actually, we have learned the DC circuits and AC circuit, and more of DC and less of AC, but actually AC also I have covered to the enough extent. And even here also, we will use the same thing. And only thing actually, the fundamental difference what we notice here it is still the AC analysis only, but the waveform is not completely. So there is sometimes we may give the complete waveform, sometimes we may cut the waveform and then give it. So except for the fact that, so the analysis, whatever we have done in the network analysis, it is exactly the same. Got it? Any questions? Fine, that's all. Thank you.